Hello, my name is Wilson Pickler. I will present this work, Demystification of Colors in Kirlian Photography as a Clinical Diagnostic Method. Kirlian photography basically consists in the photograph of luminous phenomena that occurs around objects subjected to high voltage fields. In this case, we have a finger and emits radiation. Corona may be desired or undesired. Here we have corona occurring in high voltage transmission lines. Here we have a corona for treatment of surfaces. And here we have corona Kirlian photograph. Kirlian photograph basically consists in applying high voltage to a metallic blade isolated by a dielectric, normally glass. Over the glass we place a photograph film. Over the photograph film we place the finger. When we apply high voltage to this assemble, we ionize the air around the finger and it emits radiation, luminous radiation that the photograph film registers. Discharge is a very weak phenomenon. We have initially the 1000 regime that is an avalanche. Afterwards, we have the corona before the breakdown voltage. When it occurs, the breakdown voltage of the air, it evolves for a glow discharge, normally with currents in the order of milliamperes. So in Kirlian photography, the power is very low at about 10 watts, 50 watts. So it will cause just a corona. But it may occur sparks also. We have to avoid sparks. We have to set up the system to just generate corona, a very weak phenomenon. Here we have performed the spectroscopy of corona in the same conditions of Kirlian photography, and we observed a great amount of ultraviolet radiation. The eyes can see dispersion from red to violet. So we have just little red here and some violet and blue, and the eyes will see it as a blue. But this photograph film can be sensitive for some portion of this ultraviolet radiation. So normally the photograph film will register it more blue and violet than normally the eyes can see. If we take a look at how a photograph film, color photograph film is made of, we can see that there is a layer responsible to blue, a filter, a layer responsible to green, and a layer responsible to red, an halation layer. When the radiation enters by the upside, it will work perfectly, because if you have a blue light, it will sensitize just the blue and the filter will block, because although it is sensitive to green and responsible to green, it is also sensitive to blue and ultraviolet and violet radiation. For this reason, we have a filter here. And the same would occur with red. If we have red, it's okay, it passes to the blue is not sensitive to red, filter will transmit it, and it will not sensitize the green because it is not sensitive to red, and will sensitize red, okay? So this is a perfect system. We can see that it works very well with photographs we are used in the past when it was normal to use analogical films. So if the radiation is blue and violet with great amount of ultraviolet, why we have this kind of photograph that some people try to correlate these colors to diseases, mental states, and so on? We have to answer this question. If you take a look how a photograph film holder is made, we can see that there is it's not a good alignment. There is not a good alignment between the photograph film and the blade. So it causes the formation of air gaps under the photograph film. So we constructed this model. If the blue radiation and ultraviolet comes from the upside, it will sensitize the blue and the filter will block this radiation. If the radiation comes from the upside, the opposite side, the back side, it passes to the transport anti-halation, just will attenuate it, and some portion of the radiation will sensitize the red, and depending on the intensity, it can cause mixture of green and red and cause a yellow. If this radiation comes from the top side, normal side, and bottom side, we sensitize blue and red, and so we can have the pink color. If the radiation sensitizes the green, red, we already told it may be yellow. To prove that model, we have done this blade. We cut the plastic blade, forming fillets and channels. We inserted this blade, filleted blade, between the glass dielectric and the photograph film in order to cause air gaps in very specific areas. We press all these things like this in a polyacetal base. There's a copper blade, a glass blade, a film, a felt, and acrylic. The blade, fillet blade, is placed between the photograph film and the glass film there, and there's a base with the metallic dielectric, metallic blade, and a base there under the photograph film. When we took a Kirlian photography with that filleted blade, we see this result, where we have air just under the photograph film, we have red. Where we have air over the photograph film, we have blue. Where we have air over and under the photograph film, we have a mixture of blue and red. We have a kind of lilac, a pink. Observe that this is a channel, and this is a fillet area. When we increase the exposition time, we overexpose the photograph film, and so there's a saturation. And we can prove that it sensitizes the red by the opposite side, light entering by the opposite side of the photograph film. We sensitize the red and also the green, and the mixture of green and red, we have orange and yellow. When we press all that system, all that assemble, without the fillet blade, we have just blue Kirlian photograph. Here we have another experience. We place the finger very soft over the photograph film, just touching it lightly. So the Kirlian photography showed very red. There was air under the photograph film. When we put the compressor frame, we pressed all those frames, we eliminated there under the photograph film, and we have just blue, just touching the film. When we put a little bit more force over the photograph film, for example, 15-gram force, the force that 50 grams of force of mass exerts over the film, we see that without the compressor frame, we have these colors appearing yellow. When we have that compressor frame, we press it and eliminate the air gaps. Digital Kirlian photography. We have done some experiences with USB digital camera. Kirlian camera with a transparent glass with thin film in such a order that it is transparent and at the same time conducts electricity, so we can energize it with high voltage fields and also register the light by the camera placed under all the system. The spectrum is violet and blue. There's no red, no yellow, no those strange colors. So we can conclude that it's not possible to make this clinical diagnosis correlating colors of Kirlian photography to diseases. Thank you very much indeed.